Here's a sketch of a box, and it looks like the length, width, and height are all different. And in fact, we've measured this with some unknown unit, which we'll just call a unit. And we got 5 for the width, 8 for the length, and 3 for the height. And then we marked off grid lines so that we can see the length of the edges, the area of the faces, and the volume of each layer of this box. And we can only see 3 of the 6 sides, but we know that the top is identical to the bottom, the one we can't see. The front is identical to the back, and the right side that we can see is identical to the left side that we can't see. Now let's just take a look at the top and the bottom. Each one is 5 by 8 for a total of 40 square units, and since there's both a top and a bottom, each one is 40, so 40 plus 40 is 80 square units for the total for the top and the bottom together. Now let's look at the front and the back. Each one is 3 by 5, which is 15, and since there's a front and a back, 15 times 2 is 30 square units for the front and the back combined. And then we'll look at the 2 sides. That's 3 by 8, or 24, and since there's 2 of them, that makes the total for the 2 sides 48 square units. Well, we're back to our box again, and we're going to write that the total area for the top and the bottom together is 80 square units. The front and the back together 30 square units, and the left and the right sides together 48 square units. We add all those up, and we get that the total surface area for this box is 158 square units. Well, here's another way to do it. We're going to mark that the width is the 5, the length is the 8, and the height is the 3, and we use H for height, L for length, and W for width. And then we notice that the top and the bottom were each 5 times 8, which is length times width, or LW. The area of the front and the back was H times W, or the height times the width, which was 5 times 3. And the left side and the right side was the length times the height, L times H, or in this case, 8 times 3. And then we realized that since there was 2 of each one of those, a top and a bottom, a front and a back, and a left and a right, we can write 2LW plus 2HW plus 2LH as a formula that would work for all boxes of this kind. And if you know anything about the distributive property, another way to write it is take the 2, put it outside a set of parentheses, and then put LW plus HW plus LH inside the parentheses. Either the blue expression or the orange expression will work to get the surface area for this box. Another way is to make a net. And for this box, we would mark the 8s there, the 5s there, and the 3s there. And then we can see that the top and the bottom are 5 by 8, or 40 each. The front and the back are 3 by 8, 24 each. And the left and the right are 5 by 3, or 15 each. We have 3 different numbers. Each one is in there twice. We add them all up, and we still get 158 square units, which is good because that's the answer we got the first time. And we're going to look at our box one more time. And now we're going to talk about volume. And I've colored the top layer so that you can get a good look at it, and you can see that the top layer must have 5 by 8, or 40 cubes. So the volume of the top layer is 40 cubic units. And then, since there's 3 layers, we can do 3 times 40 to get that there's 120 cubes, or 120 cubic units in this box, and that's what we call the volume of the box, 120 cubic units. We multiplied the length times the width to get the volume of the top layer. And then we took that and multiplied by the height to get the total volume. So if the top layer is LW, then it's LWH to get the total volume. And that leads to this formula. The volume of a box like this is the length times the width times the height. We're back to our tissue box, and I found one in my home. I removed the tissue so I could measure it and just concern myself with the surface area and the volume of this tissue box. I measured it in traditional units this time to the nearest ½ inch. So my length of my box was close to 9 inches, my height 3½ inches, and my width 4½ inches. Then I plugged it into the formula, and I chose to plug it into the one in orange. It would work either way, the blue one or the orange one. I plugged in the proper numbers for H, W, and L. I did the arithmetic. I came up with 2 times 87½ and I got that the surface area of this box is 175.5 square inches. The volume doesn't take quite as long. It's just the three numbers multiplied together, and there they are. I used a calculator, 141.75 cubic inches. Here's an example of a box where two of the dimensions are the same. Perhaps the width and the height, and the length is 4 centimeters, and the other two are 2 centimeters. So here's a net for this one. We could do it this way. We can see that there's 4 rectangles that are each 4 by 2 or 8 square centimeters. And there's 2 squares that are each 2 by 2 or 4 square centimeters. So the 4 8s and the 2 4s make a grand total of 40 square centimeters. Well, the other way to do it is to use the formula, and we plug a 2 in for both H and W, and we plug 4 in for L, and we do the arithmetic. We end up with 2 times 20 or 40 square centimeters. So whether we use the net or the formula, the answer is the same. The surface area for this box is 40 square centimeters. The volume doesn't take as long. Let's just multiply the three numbers. I think we can do that without a calculator. 4 times 2 times 2, I'm getting 16 cubic centimeters as the volume of this box. In this lesson, we looked at 2 formulas for rectangular solids. First, the formula for the total surface area of a rectangular solid. The surface area is equal to 2LW plus 2HW plus 2LH, where L is the length, W is the width, and H is the height. Another way to write it is 2 times the quantity LW plus HW plus LH. And the volume for a rectangular solid is the volume equals the length times the width times the height, or LWH, where L stands for the length, W stands for the width, and H stands for the height.